Hi everyone. In this video, we're going to go over the concept of gravitational force between two large objects. So that could be planets, stars, moons, satellites, stuff like that. And we're going to learn how to use this formula. The question I'm looking at has a short reading in the beginning, and there's a bunch of extra information, so I'm just going to focus in on what I really need to know. And I'm going to do that by annotating. So I'm circling the numbers and units. And that helps me see the mass of Jupiter as 1.90 times 10 to the 27 kilograms. I see Jupiter has a moon called Io, and Io's mass is 8.93 times 10 to the 22 kilograms. And I can see that it orbits Jupiter at an average distance of 4.22 times 10 to the 8th meters. I'm being asked to calculate the gravitational force of attraction between Jupiter and Io. And I put a box around Jupiter and Io because I think it's important to know what two objects I'm looking at for this gravitational force. And I also put a box around distance because in the formula that we're going to use today, we use r to represent distance between two objects. And it's important that we don't just see the first number that gives us meters and assume it's the distance. They have to actually tell you it's the distance. Sometimes they'll try to trick you by giving you the radius of a planet or a moon, and that's going to be just extra information that we don't use. So I want to make sure that I'm looking at the right number for distance. The next thing I did was I listed out all of my variables. I'm looking for Fg. I put m1 as the mass of Jupiter, but m1 and m2 are completely interchangeable, so it doesn't matter which one you put first. Then I put m2 as the mass of Io, which is Jupiter's moon, and I put r as the distance between these two objects. So I know I'm going to use Fg equals gm1 m2 over r squared, and I have everything listed except for this capital G. It is very important that you list this out because on the regions, they take off points if you don't put the unit for each number that you use. So the way I have it set up, I'm just listing out all my numbers and units here so I don't have to put the units in my equation later. So 6.67 times 10 to the negative 11 newtons times meters squared per kilogram squared. That's the value I'm using, and I found that on the front page of my reference guide. Now I'm going to plug in my numbers. I just followed the exact same format that's written here, and I just basically put each number where it belongs. It's important that we square the distance, and it's important that we don't square either of these masses. Occasionally, students will accidentally see m2 as m squared. So we're not squaring either of these masses, we're just squaring the distance. This next part is an optional step. It sometimes helps to do the numerator and denominator separately, just because there's so much to put in your calculator. If you want to, you can plug this in and hit equals and write it down, and then plug this in and hit equals and write it down. If you're not getting these numbers, double check your exponents, make sure you have negative 11, make sure you typed everything exactly as it appears, and in the denominator, make sure you are using parentheses before you square it. When I divide, I should also be using parentheses in my calculator. If you get a different exponent other than 22, that means you forgot the parentheses. And if you do get 6.34 times 10 to the something else, not 22, you don't get any half credit for that. So that's just a completely wrong answer. Alright, question 2 says, determine the centripetal acceleration of Io toward Jupiter. Show your work including the formula and substitution with units. So I'm looking for centripetal acceleration, and I put a box around of Io because when I go to list out the mass, that tells me I'm listing the mass of Io. I don't care about Jupiter. Yes, Jupiter is mentioned, but they really are asking me about the centripetal acceleration of Io. So that's really all I care about. So AC is my question mark. M is 8.93 times 10 to the 22 kilograms. I got that from the reading, and it's the mass of Io. It is not the mass of Jupiter. Then I put down Fc equals 6.34 times 10 to the 22 newtons, and that is the force that I just got in question 1. So in question 1, they asked me for the gravitational force, and now here I'm using it as centripetal force. And that's fine because the orbit of Io around Jupiter is generally a circle, so I can use it as a centripetal force. I used Fc equals mac as my formula. I plugged in these numbers, and to get AC by itself, I divided both sides by 8.93 times 10 to the 22. This is what I got in my calculator, and I rounded it to 0.71 meters per second squared. Question 3 says, state the reason why the magnitude of the sun's gravitational force on Jupiter is greater than the magnitude of the sun's gravitational force on Io. This question can trip people up because they're not asking you to compare these two things. They already told you which one is greater, and you have to explain why. So when they say state the reason, that means they're kind of telling you a fact and asking you to explain it. So the fact that they're giving us is Fg, or force of gravity, between the sun and Jupiter is greater than Fg between the sun and Io. And you have to explain why. So I would explain why using this formula, because they're talking about the force of gravity. The force of gravity is going to depend on the mass of the sun and the mass of the other object, whether that's Jupiter or Io. And it's going to depend on the distance between the sun and that other object. Now, I know that the mass of Jupiter is much, much greater than the mass of Io. If I go back to where I listed my variables in the beginning of question 1, I see that the mass of Jupiter, m1, is times 10 to the 27, but the mass of Io is only times 10 to the 22. That's a difference of 10 to the 5. That's a really big difference. It's 10 to the 5 times greater, the mass of Jupiter is 10 to the 5 times greater compared to the mass of Io. So that's a really, really big difference. And for that reason, I would say that's my answer. Jupiter has a greater mass than Io. If I have this value here, if I plug in the mass of Jupiter, that's 10 to the 5 times bigger than the mass of Io. So it's going to make a really big difference. The force of gravity is going to be a lot bigger between the sun and Jupiter versus the sun and Io. You can also see in the formula that the force of gravity depends on the distance between the two objects. So you might be wondering if there's a significant difference there. And I wanted to show you this diagram of the sun, earth, and moon. And I know we're not really talking about the sun, earth, and moon, but it's a good kind of layout for how you can picture all of the planets and their moons. So here's the sun, and here's the earth and moon. The earth and moon are too small to see in this diagram because it is to scale. So the distance between the sun and the earth and the sun and the moon is almost impossible to distinguish. They're so close to each other. It's going to be the same thing for the sun and Jupiter and one of Jupiter's moons. A moon and a planet are so close together compared to the distance from the sun that you wouldn't really be able to tell when you're looking at it on a scale diagram if the moon is closer or the earth is closer. It's just, there's barely a difference, so we don't really worry about it. And so again, for that reason, we would say the answer to question 3 is just Jupiter has a greater mass than Io. That one is a really big difference. The distances is going to be too small to even really distinguish.